In this tutorial I want to talk about salt hydrolysis. Now you should realize that salts are ionic compounds, and when acids react with bases, they go through a reaction known as neutralization, and they produce salt and water. So the salt comes from acids and bases. Now, if the acid is represented as HA, let's say, and base is hydroxide MOH, so this is parent acid and parent base. The first name of the salt comes from the base, and the last name of the salt comes from the acid, so MA-A-. So it's ionic. Now what you should realize immediately that not all salts are neutral. So there are a few cases, I'll talk about it. The first case is if you have a salt such as KNO3. You have to decide if it's neutral, acidic, or basic. What you should immediately do is look at their parents. HNO3 is the parent acid and it's a strong acid. And K comes from KOH, potassium hydroxide, which you should know by now is strong base. If both parents are strong, that means the salt is neutral. So this is a neutral salt. It has pH give and take equal to 7. Why? Because then potassium ions and nitrate ions, in this case, have no interaction or reaction with water. They have been already completely ionized, so there is no reason for them to react. So no reaction. And from now on, if you don't mind, for reaction, I just write RX, and it's a quicker way to get this communicated. The second case you might come across in IB is, for example, if you have something like sodium ethanoate. Sodium ethanoate. Now, the acid is coming from ethanoic acid, CH3COOH, which is a weak acid. All carboxylic acids are weak. The first name comes from your sodium hydroxide, which is a strong base. Now, the salt will take the character of the stronger parent. In this case, the stronger parent is base, so this is a basic salt. So that's one quick way to realize if your salt is acidic or basic or neutral. And if you say it's basic salt, that means pH of this salt is greater than 7. Now, to prove why this is basic salt, let's do hydrolysis of water. Then again, Na plus H2O, there is no reaction. But CH3COO minus, ethanoate, plus H2O, there is a reaction. And since you said it's basic, we are hoping you produce more hydroxide. And in this case, you produce CH3COOH plus OH minus. So the reason you are basic is because concentration of hydroxide goes up upon this hydrolysis. Now let's look at the third case. You might come across a salt such as ammonium chloride, NH4Cl, and you have to decide if it's neutral, acidic, or basic. Now the parent acid is HCl, which is strong acid. Parent base is ammonia, which is a weak base. Then again, you take the stronger character of your parent, and this becomes an acidic salt, meaning pH should be less than 7. Now let's just also prove this by Cl minus plus H2O, no reaction. It's already an ion, there is no reason for it to react. But NH4 plus has room to react, H2O. And since you said it's acidic, I'm hoping you produce more hydronium or hydrogen. And it is the case. You produce ammonia plus more H3O plus comes to life. That's pH, why pH is less than 7. Now you might come across another case quite often in IB that they will give you salts such as aluminum chloride or iron 3 chloride, and the question is, are they acidic, neutral, or basic? One quick way to remember, the metals that have 3+ charge, Al3+, Fe3+, due to high charge density, they're always acidic salts. So remember this, and all your transition metals are also acidic. Now the reason for that is write the equation a couple of times, then it becomes friendly. What aluminum chloride does is once it becomes, it reacts or it's dumped in water, it's going to form a complex ion. 6 H2O molecules are going to surround it. You will have dative bonds and all those stuff that you're used to, 3+. Now what happens is, since aluminum is extremely small and highly charged, it's going to polarize one of the molecules of water, and it will remove some of the electrons from it. And you have 5 molecules of water, 1 OH. Your charge gets reduced to 2+, and you release some hydrogen, and that's why the solution becomes acidic. Now in case of aluminum, in iron 3, I start writing it. You should pause the video. You should write it yourself once so you get used to it. IB has quite often asked this question. So then again, it does the same reaction. 6 H2Os become 5. One of the H2Os becomes OH minus, cancels one of your charges, 2+, and you release more hydrogen ions. So this is why these salts are acidic.